Hello everyone, I am Vander Sumbilion, and today me and my groupmate will be going to discuss the plate boundaries, faults, and breaks. Now, what is plate boundaries? Plate boundaries are the zones where two or more tectonic plates meet. The plates are constantly moving, and the way they move relative to each other determines the type of plate boundary. Now, there are three types of plate boundaries. First, convergent boundary. Second, divergent boundary. And third, transform boundary. Now let's proceed to the convergent boundary. What is convergent boundary? Convergent boundary are where two plates collide. This can cause one plate to subduct under the other, or the plates can crumple and form mountains. Now, as you can see in the diagram, you can see that there were two plates non-collide that causes other plates to subduct and created a mountain. The collision also results in the formation of various geological features and can give rise to seismic activity, like volcanic eruptions and the formation of mountain ranges. Now, there are three types of convergent boundaries. It's the oceanic-continental convergence, oceanic-oceanic convergence, and continental-continental convergence. Now, let's proceed first to the oceanic-continental convergence. Oceanic-continental convergence occurs when an oceanic plate collides with a continental plate. Also, the denser plate is usually subducted beneath the less dense plate. You can refer to the diagram below. Also, this process often leads to the formation of deep sea trenches, volcanic arcs, and earthquakes. Now, for the oceanic-oceanic convergence, this type of convergence happens when two oceanic plates collide. One of the plates is usually subducted beneath the other, leading to the formation of island arcs and oceanic trenches. Volcanic activity is common in this type of boundary. Now, for the third one, which is continental-continental convergence, this occurs when two continental plates collide. Neither plate is subducted due to their similar densities, which means the intense pressure and compression lead to the formation of massive mountain ranges. Earthquakes are common in this region due to the powerful forces generated during the collision. Now, for the next boundary, which is the divergent boundary. What is divergent boundaries? Divergent boundaries are where two plates move apart. This can create new oceanic crust or rift valleys on land. Divergent boundaries are most commonly found in the middle of oceans, where they form mid-ocean ridges. Divergent boundaries can also be found on land, where they form rift valleys. Now, there are two types of divergent boundaries, which are the mid-ocean ridges and continental rifts. Let's proceed to the mid-ocean ridges. Mid-ocean ridges are underwater mountains that are formed as the oceanic plates move apart and also formed by the rising of magma from the mantle at divergent boundaries. As the magma cools and solidifies, it creates new oceanic crust. This process is a fundamental mechanism in the process of seafloor spreading. Now, for the continental rifts, divergent boundaries can also occur within continents, leading to the formation of rift valleys. Rift valleys are long, narrow valleys that are formed as the continental plates move apart. These rifts can gradually widen over time, leading to the eventual separation of continents into two distinct land masses. The East African Rift Valley, which is in the picture below, is an example of a continental rift in the process of pulling apart the African plate. And for the third and last boundary, which is transform boundaries. Transform boundaries are the locations where tectonic plates slide past each other horizontally. This was also known as strike-slip-fault boundaries. This movement doesn't create or destroy crust, but it can cause significant earthquakes and other geological phenomena. Transform boundaries are typically found in oceanic crust, connecting segments of divergent boundaries, but they can also occur within continents. Transform boundaries are a consequence of the complex and dynamic interactions between tectonic plates. They arise from the need to accommodate relative plate motion and adjust to the stresses and changes that occur at plate boundaries. The motion at a transform fault is classified into two categories, right lateral and left lateral. Right lateral transform boundaries are those where the two plates are moving away from each other in a dextral direction, meaning that the plate on the right side of the boundary is moving to the right relative to the plate on the left side. Meanwhile, the left lateral transform boundaries, also known as sinistral transform boundaries, are those where the two plates are moving away from each other in a sinistral direction. meaning that the plate on the left side of the boundary is moving to the left relative to the plate on the right side. Basically, right lateral and left lateral movement describe the direction of motion along transform boundaries where tectonic plates slide past each other. Right lateral boundaries involve movement to the right, while left lateral boundaries involve movement to the left. Now, there are two types of transform boundaries, which are the oceanic transform boundaries and continental transform boundaries. Oceanic transform boundaries are the most common type of transform boundary, occurring in the middle of the oceans. They are characterized by a central rift valley, where new oceanic crust is actively being created. The Mid-Atlantic Ridge is the most well-known example of an oceanic transform boundary, which you can see in the picture. Oceanic transform boundaries are typically associated with vertical strike-slip faults, which allow the plates to slide past each other along a straight line. These faults can be hundreds of kilometers long and can accommodate significant horizontal displacement between the plates. While continental transform boundaries occur within continents, where land masses are gradually being pulled apart. They are characterized by a series of faults and valleys, and they can eventually lead to the splitting of a continent into two or more pieces. The East African Rift Zone is an example of a continental transform boundary, which you can see in the picture. Continental transform boundaries can involve either vertical or oblique strike-slip faults. These faults can cause significant earthquakes and can offset geological features, such as mountain ranges and rivers.
Hello everyone, I am Christine Celine Arnon Arcaluban and I am here to discuss to you about the faults and breaks. So what is faults? In geology, it is a planar or gently curved fracture in the rocks of Earth's crust, where compressional or tensional forces cause relative displacement of the rocks on the opposite sides of the fracture. Faults range in length from a few centimeters to many hundreds of kilometers, and displacement likewise may range from less than a centimeter to several hundred kilometers along the fracture surface. Faults play a crucial role in the field of geology and are of significant importance in understanding the Earth's structure, tectonics, and the processes that shape our planet's surface. Faults may be vertical, horizontal, or inclined at any angle. Although the angle of inclination of a specific fault plane tends to be relatively uniform, it may differ considerably along its length from place to place. When rocks slip past each other in faulting, the upper or overlying block along the fault plane is called the hanging wall or the head wall. The block below is called the foot wall. We have three basic types of faults: the normal fault, the reverse fault, and the strike slip fault. First, we have the normal fault. The normal fault occurs when two plates move away from each other, causing one to slide down relative to the other. Normal faults are produced by vertical compression as Earth's crust lengthens. As what we can see on the picture, when we are having an earthquake, the hanging wall slides down relative to the footwall, and that's how normal fault works. Next, we have the reverse fault. When the plates are compressed or pushed together, reversed or thrust faulting occurs. This means that one plate was pushed up onto another plate. Unlike the normal fault that the hanging wall will go down, in the reverse fault, the hanging wall will go upwards. The reverse fault results from horizontal compressional forces caused by a shortening or contraction of Earth's crust. The last one we have here is the strike slip fault. In the strike slip fault, the two plates are moving horizontally past one another like cars going in opposite direction on the highway. It is just usually moving horizontally. It will either go in the right side or in the left side. If it goes to the right side, it is called the right lateral strike slip. And when it goes to the left side, it is called the left lateral strike slip. The strike slip faults are similarly caused by horizontal compression, but they release their energy by rock displacement in a horizontal direction almost parallel to the compressional force. And that's all for the three basic types of faults. Now we will go to the breaks. So, what is breaks? Break refers to a general term that encompasses any fracture or discontinuity in the Earth's crust. It occurs in different types of rocks, including sedimentary, metamorphic, and igneous rocks. Breaks can range in size from small cracks to large scale ruptures and can be caused by various factors, including tectonic stresses, erosion, and weathering. It is also important features in geology, as they can impact the movement of groundwater, the formation of geological formations, and the occurrence of earthquakes. They can also provide insights into the Earth's past tectonic history and the forces that have shaped its landscape. Here we have some specific examples of breaks in Earth science. We have the joints, the faults, the cleavage, fissure, and lastly, the fracture zone. First, we have the joints. A joint is a fracture in rock that has no relative displacement between its two sides. Joints can be formed due to cooling and contraction of rocks, tectonic stresses, or weathering processes. Joints are also defined as cracks or fractures present in the rocks. These may be small size, extending for a few centimeters in length, or extremely extensive. Next, we have the fault. A fault is a type of break in the Earth's crust where there has been relative movement between the two sides. Faults can be classified based on the direction of movement, such as the normal faults, the reverse faults, and the strike slip faults, as what I've said earlier in my discussion about the faults. Next, we have the cleavage. The cleavage is a type of fracture in rock that causes it to split easily along certain planes. Cleavage is often observed in metamorphic rocks such as slate and schist. Cleavage is also the property of a mineral that allows it to break smoothly along specific internal planes, called the cleavage planes. Now we have the fissure. A fissure is a narrow opening or crack in the Earth's crust that can be caused by tectonic stresses, erosion, or volcanic activity. Fissures can provide pathways for a groundwater flow and can sometimes be associated with hot springs or geothermal activity. Fissures are also often filled with mineral bearing materials. On volcanoes, a fissure is an elongate fracture or crack at the surface from which lava erupts. And lastly, we have the fracture zone. The fracture zone is a large scale linear feature composed of a series of interconnected faults and fissures. Fracture zones are often found in oceanic crust and mark the boundaries between different segments of oceanic plates. Fracture zones are common features in the geology of oceanic basins. Globally, most fault zones are located on divergent plate boundaries on oceanic crust. This means that they are located around mid-ocean ridges and trend perpendicular to them. And that is all for the examples of the breaks. I hope you learned a lot about plate boundaries, faults, and breaks. Thank you so much for listening. Have a good day and God bless. Goodbye.